Hi, everyone. I think Duani had been presented myself very well, and thank you for that. My talk today will be about one part of my PhD work, which is related to examining the reproducibility with the bioinformatic domain. As the title mentioned, it will be using the PRIMAD model as a reproducibility framework with the BioCompute object as a research object in the bioinformatic domain. Our agenda reflects the title. We will define what we mean by the computational reproducibility. Then when we go through the PRIMAD model and the BioCompute object, then we will describe the study itself. Later, we will show our finding from this study in the manner of the BCO and in the manner of the PRIMAD. Later, we'll show our future work based on this study. What do you mean by computational reproducibility? Among a lot of definitions in the literature for the computational reproducibility, we choose this definition that related to the National Academy of Science and Engineering and Medicine, which is, they mentioned that obtaining a consistent computational result, so it's not identical, it's a consistent, related to the context of the experiment itself, by using the same input, the same computational step as implementation and the method with the conditional and the analysis that being used in that experiment. What is the PRIMAD model? PRIMAD model considers a framework or a roadmap for the computational reproducibility by identifying 6 acronyms that define the main element for the computational experiment. The first one, which is the platform, which is the environment for that experiment, the research objective or the goal of that experiment, the implementation, the source code or the code usually, then the method, which is represent the algorithm or the main step of the experiment, then the actor that represent what the human roles being included in that experiment. Finally, the data in 2 categories with the input as a raw data and the parameter that being used in this experiment. The interesting thing about the PRIMAD that he defined these 6 elements with the fixed and changeable manner. So as you could see in this table, which has been from the main paper, but I made some modification in it. So it defines how the reproducibility can become in different forms based on the variable that the element that's changed. So for example, if we're gonna move the experiment to another platform, that means we relocate the experiment by changing the platform. So the gain that we get it from this change, the portability of the experiment. Another thing, for example, if we're going to change the implementation of that experiment by changing re-implement the methodology of that experiment, changing the source code of it, this could be has a consequence change also to the platform, because, for example, we change the language of that code, we will run it in another platform. So it defined different forms of the reproducibility based on the change element of the experiment. One of the good codes, I found it in the paper, that the reproducibility within its different forms, it's never a goal. So we are not about verifying the work. We're trying to use the other elements of that work based on our goal from the reusing of it. The BioCompute object is considered as a descriptive standard for documenting the workflow using the JSON document, and it's the domain specific for the bioinformatics itself. So it's usually used with that domain. It's also now becoming from many years, becoming an IEEE standard for a communication between in bioinformatics field, and it's also being used as a regulatory submission for the Food and Drug Administration in the US as a communication and the regulatory document submission for them. The reason or the motivation that we lead us to use the BioCompute object is that, sorry for the slide, yeah. So the reason for using the BioCompute object is that it is related to the part of my PhD as it is research object, and sorry for that, yeah. So my PhD topic is related to investigation of the reproducibility with the research object. From that title, the motivation comes for using the BioCompute object as it's a research object implementation, and it is promising the reproducibility for the bioinformatic workflow. To go in the deep with the BioCompute object and to show how it is a well descriptive for the bioinformatic workflow, it is divide the experiment into 8 domains. Each domain describes the experiment from its phase. So the provenance describes the experiment as a whole with the top level, whereas in usability and in description domain, it describes it from the conceptual view. So what is the main steps for the workflow, how it is, why it is used. Then there is the other, which is the execution parameter, input and error. It's go within the workflow implementation itself. So it's usually platform dependency. Then they have an extension domain to include any extra description for the workflow that is not being described by this by the description of the BioCompute itself. As you can see that we finished the first 3 main points by the reproducibility, what do you mean by PRIMAD and BioCompute. Now we're going to go to describe our study. The study we start by identifying a framework for the reproducibility, and we choose the PRIMAD. Then we choose an application for the research object, which will choose by the BioCompute object as an application or a development of the research object within the bioinformatic domain. Then we choose a use case from the BioCompute object database, and we focus to choose a published one, not an arbitrary one from their database. Then we investigate more within this use case by mapping it to the specification of the in the BCO itself. Then we did the systematic mapping. By the beginning, we start using as a general mapping between both, just the conceptual view. So what is the main attribute in the BioCompute object within their domains and the main element of the PRIMAD model. Then we go deep in the second and the third step with the details of the use cases by the value to show the functionality of each attribute clearly. This table shows one of the results of the steps. You could see that here the domains, and this is the field of attributes of that domain, and this is the value that we get it from the published use case, which is this is the number of the database and the database, and this is the paper that is being published, the use case. And we could see that how we map the dimension of the PRIMAD to the use cases. I think this table shows how the BCO being tailored descriptive to the reproducibility by identifying many details about the experiment compared how the PRIMAD is more general and abstract description for the reproducibility. And this is which go let us go to describe our result in both of them. So one of the main results that we find it for the BioCompute object that we think that we need like more conceptual descriptions. So we need to describe the experiment from a high level. What is the main goal of that experiment? Because in the use case, we find the goal is being descriptive in the name, not written inside the description. And also, what is the methodology, the theoretical methodology that's being followed by in the experiment? And later we found the BCO, developer did that. The next one, in the description domain, we give an idea improvement to give a hint of the keyword that's being used for another attribute that for being used in the experiment. In the use cases, we found these keywords, but we think that if we add a hint for the user for the type of the keyword that he included for his experiment, it will be more useful. And also hint the user to give a meaningful for the data file's name, it will show the functionality more. Also, we found it's important to identify the accessibility for each file that's being used in the experiment. Is it will be open access, or will be a specific authorization, or can be only used by a proprietary platform or an open platform. So the resource accessibility, it should be identified for each file for the experiment. If any reproducibility study has been did for this, I think maybe it should be reported within the BCO, and also any publication has been done. The data file has been mentioned during the BCO in many times, and this is cause kind of misunderstanding between the number of files in different domains. So I think it should be a balance between describing the files and giving a more clear and more descriptive for the whole experiment, and also a more deep and that related to the platform. So we need to consider both perspective once we report the experiment. For the PRIMAD, we think about, we found that the model is a good one for, it's a well structured for describing the computational experiment, but in the same time, it needs some depth with its dimension, and that's what we found it based on our mapping and examining. So we found that each dimension from the PRIMAD needs some depth based on these aspects that we get it from the BCO attributes. So we need the time reflection in some dimension, like the platform and the implementation and the data. And the version also, like the review process, the variation difference, which is reflected the fault tolerance for the platform and the implementation, and also in the data. Actually, it's not only our result. This result has come also from another work before us. They found that the role of the human and data categorization should be identified and go in depth in the PRIMAD. This leads us to our next step within my PhD work. So we believe that the PRIMAD is a good recipe for the computational reproducibility. However, it needs more investigation with other disciplines. So our work was only with the bioinformatic discipline. So we think it needs more investigation to address the challenge of reproducibility in other domains. And this was our next step. So as you can see in this table, it's identified the main science disciplines as a formal, physical, life, and social science. Our first step was identifying it, do the examining of the PRIMAD model within the bioinformatic. Then now I think we did also some work with other domains by picking use cases from the literature from the main science domain. So we took a use case from the astronomy, machine learning, and finance, and address the reproducibility with each these domains. How this investigation has been done or doing. So we use some standard as we did in bioinformatics by the IEEE standard for the BioCompute Object. From the literature, we check the reproducibility checklist or reporting guidelines or investigation reproducibility study in some domains. And also we did a survey and interview. This work has been now in the preprint in archive, and the data has been associated with it in Zenodo. And I need to thank both of my supervisor, Prof. Carol and Dr. Stian. This work could be not done without their help and vision and supervised work. Thank you. I'm open now for any question.